Hi there. Today, we'll guide you through creating a 3D animation using both video and text with DeepMotion's Gen AI animation tools. The story we're crafting features an energetic young man who starts off performing a powerful kung fu sequence. Then, he seamlessly transitions into a baseball player, delivering a dynamic pitch, and finally ramps up the energy with a thrilling basketball dunk. How cool is that? 3 different sports in one fun and action-packed animation. Traditionally, animating something like this would be a daunting task, but let's see how DeepMotion AI makes it simple and effortless. First, we found a reference video for the Shaolin Kung Fu martial arts move. Here it is. Check out this cool young guy. He's performing a Shaolin Kung Fu sequence. Next, we want him to switch gears and throw a baseball pitch like a pro. So, we found another reference video for that. Perfect, this is exactly what we need. Lastly, I wanted our character to perform a basketball dunk, but I couldn't find a reference video for it. So, why not create it using a text prompt? Let's say, a basketball player runs to the board, jumps and dunks. Now we have 3 raw assets: a Shaolin martial arts video, a baseball video, and 1 line of text. Can we transform these into a seamless, athletic animation? Let's find out how to do it with DeepMotion AI. As you may know, DeepMotion is a cutting-edge generative AI platform for 3D animation. It enables AI-powered motion capture from video and allows you to generate and edit 3D animations using natural language with SayMotion. Let's dive into the DeepMotion portal. First, we'll use Animate 3D to transform our video assets into raw 3D animations. From there, we'll use SayMotion to refine them and seamlessly merge them into the animated story we're creating. Once we launch the Animate 3D portal, navigate to the Create menu. Drag and drop the video and click the Create button. Let's start by capturing motion from our baseball pitch video. Simply upload the video and hit the Create Animation button. That's it. The backend will process the video and use AI motion capture to generate 3D animation from the 2D footage. This animation serves as a building block for the animated story we're crafting. Great! As you can see, the 3D animation has been successfully created. Let's take a look at the preview. Here it is. The 3D motion of the baseball pitcher has been accurately captured by the AI. While the core motion looks good, there are a few issues to address. For example, there are some noticeable shakes, and when the character throws the ball, it's directed downward instead of forward. These details need refinement. To fix this, we can export the animation to SayMotion for further polishing. Let's hit the Export to SayMotion to Refine button. Let's go ahead and do that. This will export the AI motion capture we just created into the SayMotion platform. SayMotion is a natural language-based platform for generating and editing motions. In this step, we'll use SayMotion to refine the captured baseball motion with AI. As you can see, this is the original motion we just brought in, ready for editing and enhancement. There are some noticeable shakes, and the arm swing isn't quite right. So, let's refine it. Go to the Edit menu and select the Refine tool. Here, we'll set the creativity level to 0.3. As you may know, a higher creativity level allows the AI to replace more details using its generative model. At 0.3, we're telling the AI to replace about 30% of the motion to make it smoother and more natural. Next, we'll select the number of variants. Let's go with 8 variants. Generating multiple options is always helpful because it gives us more choices to find the best result. For the text prompt, we'll simply describe the action we want to refine. We'll say, a person is swinging their right arm to pitch the ball. That's the key motion we're looking to improve. Now, let's hit the refine button and let the AI work its magic. Next, the AI will process this input using our generative AI model to refine the animation, generating several variants for you to choose from. The goal is to make the motion smoother and more natural overall while fine-tuning the details to better align with our text prompt. In this case, the text prompt focuses on improving the arm swing for the baseball pitch. By doing this, we aim to achieve a more accurate and natural-looking swing in the resulting animation. Alright, we've just generated 8 variants of our refined baseball pitching animation. Let's take a look. As you can see, all the motions are noticeably smoother than the original. The shakes have been removed, but now we need to pick the best variant for the pitch. I'll replay the pitching section a few times to evaluate them. Each variant has subtle differences. Some are closer to what we're aiming for. Remember, in the original motion, the character was throwing the ball downward toward the ground, but we want him to throw the ball forward. Let's focus on finding the variant that achieves that. Alright, personally, I think variant 7 looks the best. It really stands out. Great! I'm happy with this refined baseball pitching motion. Let's go ahead and select that one. Let's say, I want to extend the motion a bit, using the In-Painting tool. To do this, we go to the Edit menu, and select In-Painting. The In-Painting tool allows you to add or modify sections of the animation. You can position the In-Painting section either within the existing animation or beyond its current boundaries to extend it. In this case, we'll start by trimming the animation to remove any unnecessary or boring parts at the beginning. This ensures we're focusing only on the key action we want to refine or extend. After the baseball player finishes pitching and turns back, we want him to transition from walking to running. To do this, I'll add an In-Painting section at the end of the animation, approximately 2 seconds long. For the text prompt, I'll simply input, "A walking person starts to run." This will guide the AI to generate the desired motion seamlessly. The goal here is to use the In-Painting tool to extend the pitching animation by adding a sequence where the character transitions from walking to running. This will ramp up the motion, setting up the character to seamlessly transition into the next animation, a basketball player running toward the hoop and performing a dunk. Alright, let's see how this works. The tool generated 8 variants where the character performs a baseball pitch and then transitions into a run. It's doing exactly what we asked. Now, let's review the variants to find the best one for the walking to running transition. Personally, I think variant 6 looks the best. The character pitches, turns around, and smoothly ramps up into a run. There is a minor issue. The foot appears slightly sticky to the ground during the transition. However, we can address that later in the optimization stage using the foot locking mode. For now, we're happy with variant 6 as our refined motion. Now that we've completed the first scene, the baseball player pitching, it's time to move on to the second scene, a Shaolin Kung Fu performance. Let's get started. Again, we'll drag the Shaolin video into Animate 3D, and since the performer is a young kid, we'll select a child character to better match the motion. Next, click the Create button. I'll leave all other settings as default for now. Of course, you can optimize the motion capture quality and fine-tune the parameters if needed. Alright, it's done. Let's preview how it looks. As you can see, Animate 3D has just successfully converted the video into a 3D martial arts motion. The input video posed several challenges. It features fast, intricate martial arts movements, and the performer is wearing loose clothing, which can make it harder for the AI to capture the motion accurately. Despite these difficulties, the basic structure of the motion was captured quite well. I really like the pacing, and most of the punches and jumps are accurately represented. However, there are some noticeable artifacts, such as slight shaking in the character, and areas where the motion could be smoother. To address these issues and remove noise, we'll use SayMotion for refinement. Let's go ahead and click the Export to SayMotion to Refine button to improve the animation. The Shaolin Kung Fu martial arts animation is now exported to the SayMotion platform. During the export, the motion is automatically retargeted to the default SayMotion bot for further processing. Here's how it looks after being imported into SayMotion. Generally, imported motions already appear a bit smoother, but to make it even better, we'll use the Refine tool. Go to the Edit menu and select Refine tool. This time, we'll set the creativity level to 0.1, allowing us to retain most of the intricate details of the Shaolin martial arts performance. If we were to use a low setting, like 0.1, only minimal changes would be made, focusing on subtle improvements. Next, we'll select 8 variants to generate multiple options to choose from. For the text prompt, we'll provide a general description of the motion. A person performs Shaolin style martial arts. Now, let's push the Refine button and see the results. Great! The refinement is complete. Let's review the variants. You'll notice that all of them are smoother and more natural compared to the original motion. Each variant has subtle differences in how the movements are performed, giving us plenty of options to choose from. I'll go with variant 3. Alright, we've chosen variant 3 as our favorite for the Shaolin Kung Fu martial arts performance. Overall, it's a smooth motion, but there's room for further optimization. First, I want to change the character to a more realistic one. Second, I'd like to optimize the foot-locking mode. To do this, we'll use the Rerun tool. The Rerun tool lets you adjust post-processing parameters, including which character the motion is retargeted to. For this animation, we'll switch the original character from the default SayMotion bot to more athletic character, Remy. Let's apply this new character. We'll also tweak the foot-locking mode. For fast movements like this, we'll use the grounding foot-locking mode. Grounding prevents excessive foot sticking to the ground, creating a motion that feels more agile while staying on the ground. With these 2 parameter changes, we will perform a rerun to generate a more realistic and fluid animation. Let's see how it turns out. As a SayMotion user, you have access to the Rerun tool, which allows you to quickly polish animations by adjusting various post-processing parameters. While the raw motion itself remains unchanged, we're using this tool to retarget the animation to a different character, giving it a fresh and more tailored look. Alright, with the new character and the optimized foot-locking mode, the motion looks much more fluid and natural. That's a great improvement. Now that we have the second piece of the animation, the Shaolin Kung Fu sequence, ready, let's merge it with the first piece, the baseball pitching animation, to create a longer, seamless animation sequence. Let's move on to that. For that, we're going to edit. We'll use the Merge tool to combine the Shaolin animation with the baseball animation. Start by adding a new merge and selecting the Shaolin Kung Fu animation as the first piece. Then, choose the baseball animation we processed earlier as the second piece to merge. Here's how it will work. The sequence will begin with the Shaolin Kung Fu performance, and transition seamlessly into the baseball animation. The throw is solid, the turn is clean, and the character transitions into running as expected. The system will generate a transition piece to connect the 2 animations. Underlying, the model analyzes both animations and figures out how to generate a smooth connecting motion that transitions naturally from the first animation to the second. Let's check out how it looks. Here we go, he's performing the Shaolin Kung Fu, finishing the sequence smoothly. Then, it transitions seamlessly into the baseball pitching motion. After the pitch, he turns around, walks, and ramps up into a run. Alright, we now have the first two pieces ready. The final step is to add the last piece where the character runs to a board and performs a basketball dunk. For the basketball dunk, we don't need any video reference. This time, we'll create the motion entirely using a text prompt. Let's head over to the InPainting tool and add a new InPainting section. We'll make this section approximately 2 seconds long. As described in our original vision, after the character completes the baseball pitch, we want them to start running toward the basketball hoop and perform a dunk. To ensure a smooth transition, we'll overlap this InPainting section slightly with the ending of the baseball pitch animation. Next, we'll enter the text prompt. Let's copy and paste this text prompt over and apply it to generate the motion. Save the prompt. And hit the Generate Animation button to start the InPainting process. For this third piece of animation, we're not relying on any video assets. Instead, we're using natural language to prompt SayMotion to generate the motion. Language is a highly flexible tool for describing any animation you can imagine. Because of this, we don't always need reference videos. Sometimes it's much easier and faster to describe motions using just words. Let's see how it turned out. As expected, the young man starts with Shaolin-style martial arts. Then, he transitions seamlessly into pitching a baseball. Amazing. After the pitch, he turns around, starts running toward the basketball hoop, and finishes with an incredible dunk. That's awesome. Everything flows together beautifully. Once our 3-scene animation is complete, we can export it as either a video or a 3D asset. To export as an MP4 video, toggle on the MP4 output option. You can select a studio background and use a green screen as the background color, which makes it easier to integrate with other video editing tools later. Next, we'll set the camera angle. Let's choose a 25-degree angle from the left side for a dynamic perspective. Finally, push the Generate button to render the MP4 video of the animation. If you'd like to export the animation as a GLB file, simply select GLB and click the Download button to save it. Once downloaded, let's check it out. Yep, it looks just as expected. You can now import this 3D animation into any digital content creation tool for further polishing or integration into your project. It's that easy. Now that our MP4 video has finished rendering, we can download the result. Let's open the MP4 and check it out. Here we go. Our young man performs an impressive Shaolin-style martial arts. After completing the martial arts, he seamlessly transitions into throwing a baseball pitch. Once he's done, he turns around, starts walking, picks up speed, and runs toward the basketball hoop to finish with an epic dunk. As you can see, with DeepMotion's generative AI, we can quickly create complex, multi-scene animations using both video sources and text prompts. It's an incredibly powerful and efficient way to bring creative ideas to life. And with SayMotion, DeepMotion's generative AI platform, you can seamlessly assemble everything into a complete 3D animated video or 3D asset. From here, you can further edit the video, replacing the background in video editors, or refine the 3D asset using any 3D DCC tools. Thank you for watching. That's our tutorial on creating a 3D animation using both video and natural language with DeepMotion's generative AI.